All right. Hello and welcome, everyone. Thanks for joining us today. We are very excited to have you on. In this webcast, we will be covering a hot topic on how to secure your applications in a cloud-native world by leveraging zero trust principles. My name is Agnes, and I work on the marketing programs team here at GitLab. I'm joining you from Jakarta, Indonesia today. We'd love to hear where everyone is tuning in from, so please use the chat function to say hi and tell us where you are in the world. Before we get started, I'm going to cover a couple of housekeeping items. First, feel free to ask questions throughout the presentation. You can use the Q&A function at the bottom of your screen for that. We'll have dedicated time for questions at the end of the webcast, but you can go ahead and send in your questions as you think of them, and we'll make sure to get to them at the end. If you're experiencing any technical difficulties, you can use the chat function to get in touch with me, the moderator, for help. Our presenter today is Cindy Blake, GitLab Senior Product Marketing Manager, specializing on security topics. We're going to launch a couple of polls throughout the webcast so we can learn more about you. That way, Cindy can tailor the presentation accordingly. With that, I'm going to launch our first poll. All right. Thank you for participating in the poll. Now, I'm going to turn the presentation over to Cindy.
Oh, I was on mute. Thank you, Agnes. I appreciate that. Looks like we've got a pretty evenly split group between DevSec and Ops. Fairly evenly split there. So today, we're going to talk about. We're going to talk about the need for taking a different approach to securing your cloud native applications and serverless apps and sort of the whole new direction of application development. A lot of the security methods of the past are not going to work in the future or are going to be insufficient when used by themselves. And there's a couple of examples that highlight this. I know everybody kind of starts with examples of attacks, but these are really different because they involve what I call the next generation software, the newer infrastructure. And so you have to think about how you secure next generation software a little bit differently. And, it's not just a matter of scanning your applications anymore. There's new attack surfaces. And as we saw a few weeks ago with Capital One, misconfiguring those attack surfaces can be huge. I think going forward, misconfiguration will probably be one of the biggest concerns, because what happens is when you look at all of the new layers, you've got cloud services, containers, Kubernetes, or other orchestrators. Each one of those layers has levers that you can pull, and if you misconfigure any of those, then you are opening yourself up to a risk. Application security is not new, but it's hard. And a lot of people either don't do it at all or may just scratch the surface. But it's really becoming much more important that you take a hard look at application security. Applications continue to be the prime target of cyber attacks, and that's usually the way that that data is stolen and that access is taken and that sort of thing. So applications continue to be really, really important. And a lot of it comes back to a lack of hygiene. if you're not scanning your applications for vulnerabilities, if you're doing sloppy things like putting passwords in there, hard coding passwords, it's those simple things that keep biting people over and over and over. There's lots of different risk reports out there, and the vast majority of them point to, established exploits that have been around for a very long time that just continue to get reused. Application scanning tools and monitoring tools are expensive, and you can't just plop them in like you can network security. You can't just put in a firewall, and you can put in a firewall and not have to do a whole lot to it other than some tuning, whereas application security tools, they really require an integration with the people and processes end of things, because you're dependent upon people using them correctly, using them consistently, and all of that, just creates more difficulty for application security. And collaboration is hard. I did a little bit of a focus group with some developers, and I asked the question about, where do you go if you find a vulnerability and you're not quite sure how to remediate it? Who do you go to? And that collaboration is challenging. There's not enough security people. The security people lack the context of understanding how to fix that vulnerability within the context of that particular code. And so there tends to be a lot of silos, and the tools kind of reinforce the silos. So let me ask, out of curiosity, Agnes, I want to do another poll here and see how many of your applications, percentage-wise, and I know this is kind of rough ballpark, do you scan for vulnerabilities before production? That's one of the kind of basic hygiene elements, is, are you scanning your applications? And a lot of people will scan the most mission critical, expecting that they're being more secure and managing risk that way. But if you look at Target and some of the other exploits that have been out there, or attacks that have been out there, oftentimes it is the backdoors that are less protected that become the problem. So it looks like only 24% are scanning, the majority of their applications. And the majority are, 50% of you are scanning less than half the time. So it's, there's a great picture that I've seen where, you put all the locks on your door and you leave your window wide open. That's what you're doing, really, if you're not scanning all of your applications all of the time. But in your defense, the tools haven't really allowed that. And so, you really have to take a different approach, because what we've been doing just doesn't work that well going forward. And some of the problems that are associated with modern software, the code changes faster and faster. So DevOps is very iterative. And if you're doing cloud native or serverless, you're probably doing DevOps. And scanning all of your applications at the end of the process just doesn't fit very well in that iterative life cycle of DevOps. You've got APIs and microservices. So what's happening is you're breaking down those large monolithic applications into smaller and smaller pieces, and it allows you to achieve your business values for those changes faster. It allows you to be a little bit more flexible and nimble, because you can change one part without affecting everything else. But it also makes it harder for the traditional application security methods to work. The current application security really doesn't scale very well. It's pretty, especially if you look at penetration testing, it's very manual and dependent upon warm bodies to get it done. And yet security people are some of the most difficult to hire. So, I guess I'm probably preaching to the choir a little bit here, but the bigger challenge really is thinking about how software changes in cloud native in a serverless environment. If you think about it, you're disassociating the application from its hardware. So by containerizing an application, I can take that container and I can run that container anywhere I want. So I can run it in the cloud. I can run it on-prem. I can run it on my laptop. And so network security, which assumes that there's a perimeter to defend, really becomes much more irrelevant. There's no longer that perimeter, because the perimeter now is just the application itself and the container. So you really need to think differently, because network security is not going to be kind of your fallback for protection. Now, it's probably worth explaining what is cloud native and just level setting on cloud native and serverless to make sure we're on the same page. The new stack has a really good definition. There's lots of different definitions for cloud native, but I like theirs, and they're all somewhat similar. They revolve around the use of containers that have usually an orchestrator that automates the use of the containers. They have microservices that I mentioned. There's APIs that connect those microservices. So it's not just a matter of authenticating the person that's accessing the app, but an app that's accessing an app as well. And then, you've got the fact that things spin up, spin down, environments spin up, spin down. So it's much more ephemeral. So you really need to rely more on policies and automation of those policies. Oops. And these three main building blocks of cloud native: containers, orchestrators, and microservices, they represent new attack surfaces, and security tools to help protect those attack surfaces are somewhat fledgling. Each one of these, as I mentioned, comes with different levers that you can pull. In fact, the default settings for each of those are not the most secure defaults as well. So understanding what levers to pull, how they interact, how they work together, that's really an important new area for cloud native applications. Now, when we look at serverless in my mind, you can argue technically whether it does or not, but in my mind, serverless takes cloud native a step further. So with cloud native, I am containerizing my applications. I can run them anywhere. With serverless, I don't even care where they're run. And I'm completely disintermediated from the operations side of things. So as a developer, I don't have to worry about how an environment is partitioned and set up and allocated for my application. It's all done in the abstract for me. And so it takes that microservices kind of even a step further. Things become event triggered, and when they're event triggered, they're super fast. You can't rely on manual interventions at that point. You really, really have to have automation and automate your policies. Let's take a poll here if we could, Agnes. I'm curious to see how many of the folks in the audience are developing cloud native or serverless applications. I believe it's somewhat fledgling in terms of volume of, or I should say percentage of applications. But yeah, this sort of confirms my suspicion that most people are at least dabbling in it. So here we've got about 2/3 of the participants are developing cloud native or serverless applications. So, this really hits home for a lot of you. All righty. Yeah. So I'm going to move on here. So I know there's a lot of text here, but I got this from an SE Magazine article, and I just thought it did such a good job of articulating this that I wanted to use the quote as is. In DevOps, you're much more, I mentioned iteration, and things are much more iterative and smaller chunks. So, how do you swallow a whole elephant? A bite at a time, right? It's a matter of taking pieces. But when you put all that together, it becomes continuous. So continuously written, updated, built, deployed, with continuous integration, continuous testing, all of that automation to push it out there. You've got containerized images. You've got the abstraction of the hardware from where the software is run, and that really strong reliance on automation. So let's dig into this just a little bit more. Application security has been historically thought of as scanning, whether it's manual through penetration testing or automated through static and dynamic testing. And then came IAST because DAST wasn't early enough in the life cycle. So we've added different types of scanning for vulnerabilities. But in this new world of next generation software, scanning isn't going to be enough. There's a lot more that needs to happen. So in addition to scanning, you need to have remediation. And it's not just enough to find the vulnerabilities. This has been a problem for a long time. Hey, I found 10,000 vulnerabilities. Now what? You've got to go and remediate those as well. So in this automated environment that's much more rapid, how much of that remediation can be automated? Think about automating the easy stuff and focusing on the exceptions. Not only that, but from a development standpoint, you want to do the scanning and remediation, but from a production side of things, you want to make sure that you are protecting those applications as they're running. And so that involves a variety of needs, from monitoring, detection, and again, remediation during production. Not so much, maybe it's a remediation of a vulnerability for a 0-day, or maybe it's a remediation of, some other real-time exploit or change to the system. Policy compliance and auditability really become key, because as I mentioned, you want to take your policies and automate them. So policies kind of come to the forefront. They've been really mostly focused on compliance, and compliance generally is like the lowest common denominator. So what's the minimum that I have to do in order to not get fined and get into trouble? But most people go beyond that compliance level. And so policies are getting there as well. So policies used to be mostly for compliance, but now you really need policies as your guardrails, so that as you're flying down the highway of software development, you've got some guardrails to keep you in check. Auditability, understanding who changed what, where, when, why, becomes really important, not only for forensics, but also for improving the process. So just as DevOps improves the processes continuously through monitoring and metrics, security should do the same. And then last but not least, the platform that you use to develop your software in the first place needs to be secure, so that you're not injecting opportunities for either for just human error or malicious intent. So let's look at these items here just a little bit further. And I'm going to focus mostly on this production application protection, because that's really the crux of the discussion around zero trust, and how to take the zero trust ideas and apply them to a production environment for your applications. Some of the rest of this it's very related, and it will kind of shake out as a related concepts. You'll see here as we go through. So I want to level set on zero trust in general first. Zero trust was such a hot topic at RSA that I think it made it in the top 3 terms at the RSA, being the security conference in the spring. It's a hot topic, but it's been around for a really long time. And I think the reason why it's becoming a hot topic is going back to the velocity of development and velocity in general of the business and IT, and that automation. And so, setting up those policies and running with them. So with zero trust, it's more about process. There are tools that will enable each of these items, but think of it more as an architecture or framework and a process that you're using in order to achieve a goal. And the goal is shifting your control. This is the traditional zero trust goal, is shifting your control from the perimeter, so managing endpoints and your network access, to assuming that the bad guys are going to get in. So instead of trying to protect my perimeter, I'm going to have policies around individuals, assets, and endpoints. So it's about the user. What can they access? What should they be able to access? The device they're using, is it a trusted device or could it have been corrupted? What asset are they trying to get to? And, it should be encrypted, but so that only the authorized users in the correct roles are allowed to get to it. And all of this is in real time. And so authentication is really, really important. And that's where compliance comes in, because that's part of compliance, and it's just getting stronger and stronger now. Now, the difference though between a traditional zero trust and what I would say we need to layer on for applications, I'm not saying abandon the traditional, I'm saying what has to be added for applications is that now it's not just users that are accessing the assets and the applications, the logic that work on those assets, but it's other applications and microservices and orchestrators. And so all of those elements need to fall into this process. So you've got APIs, you've got secrets, all of these pieces get added on when you start looking at applications in terms of that zero trust mentality. And that mentality is, it's going to happen. Stuff's going to happen. So the Capital One breach that I mentioned earlier was a good example where, it was misconfiguration. And misconfiguration is just one of many things that can expose data, but it's going to happen, and it's going to happen more and more as things get more and more complicated and there's more levers to pull. So rather than trying to keep everybody out, just like zero trust for networking, zero trust for applications should assume that there will be failures. Bad guys will get in, they'll get access to the apps. You've got to architect for resilience. I come from a background, well, I was a developer way long time ago, but I was at Compaq for a long time with hardware. And I remember when clusters first started coming out. And before clusters, we took the server and we made these smart servers that could detect. They did a lot of monitoring of the storage and the disk, and it would say this one's overheating or it's not functioning properly, so we're predicting that it's going to fail, so let's swap it out before it fails. But that quickly was taken over by the concept of instead of trying to find the one that's going to fail before it fails, just expect they're going to fail and treat them like a commodity and have them clustered so that one fails, you have an automatic failover to another device, and you can hot swap, pull out the one that broke and replace it, and your processes just keep going because of that automation. And so we can apply that same resilience towards applications and that application environment. So expect that they will come up against bad guys, but try to harden them. Follow good hygiene and do some things to harden them wherever they run. But then instrument, monitor, detect, protect that infrastructure in which they run, so that when something happens, not if, but when something happens, you can quickly take action and rely on some automation to build in some of that resilience and that security. I think this is the summary really of how to harden an application and make it resilient. You need to practice good basic security hygiene, and I'll get into each of these a little bit more, but good security hygiene. I mentioned most exploits, most breaches use the same exploits over and over again. It's because they work. And it's because people are lazy and they don't patch their applications and they don't run security scans and those kinds of things. You need to monitor and detect security issues and have an automated response wherever possible, and particularly in a production environment. And then build all of this on a foundation of standardization, policy, automation of the policies, controls, so having audit controls and the like, and continuous improvement. So if we look at basic security hygiene, what is that? Well, it's having policies. Some people don't even have policies. You need to have policies. Things like, do we or don't we permit moving an application with a critical vulnerability into production? Some people do, because their velocity is so fast that they come back and they'll accept that risk for a very brief period of time because their velocity is so fast that they'll come back and fix it the next day, the next hour, the next week, what have you. Scan every code change. That's not possible with some of the traditional application security scanning tools. So you need to think about, how can I embed all of this scanning in my CI/CD process in an automated fashion? So I don't have to think about it, the developer doesn't have to think about it, and everything's handled on an exception basis. And then, as I mentioned, comply with industry regulations, because they are kind of the lowest common denominator. The way that you can make your scanning as iterative as your development is by building it into that CI/CD. So it becomes a very tight feedback loop that's very actionable for the developer. The developer commits a piece of code, the scan is automatically run, they see the result, and they know it wasn't John 2 cubicles down that caused the problem. It wasn't something that's been lurking out in the code for 2 years. I did it. I just now did it. While it's still fresh on my mind and I've got the code in front of me, I can fix it or not. There's multiple paths, but I can deal with that while it's fresh. So on the production side of things, you need to build upon some of the traditional zero trust. So role-based access controls, multi-factor authentication, all of those things still need to be done. I'm not advocating that they don't. I'm advocating you really need to do those things, classify your data, know what's the most sensitive, look at who can access that sensitive data, what's their role, automating all of those policies. But then at the same time, you need to think about some additional things that maybe you hadn't thought about. So how do I monitor, detect, and take automatic protection response around my APIs? So now I've got all these APIs that are dealing with much smaller pieces of code. How do I protect that? How do I monitor that? Cloud service, and most of the cloud service providers have security tools. But you need to make sure that you've got policies for that and that you're automating that wherever possible. Containers and orchestrators. I've got a good presentation. If you Google Kubernetes Day in India and my name, there's a presentation that I did where I went through an attack scenario and showed how an attacker could actually enter a container, go through the orchestrator and get keys to the AWS kingdom as an example, just an example. But, and once they have those keys to the kingdom for that cloud provider, then they're pretty carte blanche in terms of what they can do. And assuming that because all of my controls are appropriate for the cloud service itself doesn't necessarily mean that there isn't a backdoor to wind your way through to get in. So make sure that you're looking at those. And then authentication, as I mentioned, the traditional zero trust is all about authenticating the user and the device, but you need to also think about authenticating the application to application element of this. And then auto remediation to automate any of those low-hanging fruit opportunities where you can allow the machine to take over for you. standardization is really important, and part of it is around compliance, and you need to have common controls in place. And the list on the left here is kind of an example of some of the common controls. And a lot of these are common across industry regulations. So pretty much they all require some degree of security testing. They all require some degree of auditability, segregation of duties. So you don't want the person that's creating the code to be the same one that pushes it to production, because then they could put in there, round the nearest cent to my bank account or what have you. These common controls are really important, and having a single application across the entire software development lifecycle can help you simplify that. The more important thing, or as important thing about that single application, is having a consistent software development lifecycle. Many of the customers that I've talked to, where they're coming from is having, each development team has their own pipeline process, their own tools, their own policies. And that is really going to hurt you on the auditability side. One of the cool things about automation with regard to auditability is if you automate something, you just need to show an auditor what your automation method is, and the rules within that. You don't have to take samples of an infinite number of examples to make sure that you're following it. And so it can really simplify your auditability and your audit process if you've got these tools in place and you've got consistency everywhere that you turn. It also improves with that end-to-end visibility, which is not only important from an auditing standpoint, but important from a process improvement standpoint. So if you really want to know where your bottlenecks are, make sure you've got that end-to-end visibility for the entire development lifecycle. Know where things get off the rails repeatedly so that you can hone in on and fix those. And so, bottom line is, just like Zero Trust has lots of advantages from a network standpoint, those same characteristics and qualities apply if you take that same approach from an application standpoint. Lateral movement's harder. If you're authenticating app to app, it's going to be much harder for an adversary to tread laterally and move from containers to Kubernetes to what have you. Stolen credentials are less valuable. If you've got multi-factor authentication and you've got a rotation of your keys and all of those things, all of those are just good hygiene. Known vulnerabilities that are easy to exploit will be less frequent if you're practicing good hygiene. In the case of Zero Trust networks, that tends to be thought of as a network exploit or malware. But from an application standpoint, it's really about also malware, and thinking about things like cross-site scripting and SQL injection and those kinds of things. If you're practicing good hygiene, it's going to be harder to exploit those common things over and over. And then non-targeted attacks have less value. So, you're less likely to be the random victim of a drive-by attack in terms of just a broad-based attack, which, by the way, is a common thing when it comes to dependencies, because open source code and those libraries tend to be used by a broader number of people. They have a much bigger blast radius, and so that becomes a really sought after target for the drive-by casual things where an attacker just wants to wreak havoc and not specifically targeting you. So if you're scanning your dependencies and you've got all of this good hygiene in place, then you're less likely to have problems there as well. So I think, Agnes, we should turn it over to questions. I've been talking for a bit. Do you have any questions lined up for me?
Yes, actually, we have a couple of questions that came in through the chat and Q&A.
Okay.
So the first one being from Anand. Anand asked, who should be responsible for scanning security vulnerability? Dev team, QA, operations, security team before the production release? That's the first.
Well, if you're taking a traditional approach, it almost always falls to the security team, but that really doesn't scale. And so the way to make it scale is to enable your developers. So if you have every code commit automatically scanned, then it's doing a couple things. It's enabling your developers, it's automating, using automation to cast a broader net. And by enabling the developers to find vulnerabilities themselves, they have three choices. They can fix the vulnerability, which would be ideal, because it's all right there and they're iteratively testing and, check in their code, look at it, make sure that the result looks right, make changes. So it's all in their workflow. The other choice that they have is to create an issue, which if you've got a tool that talks to your ticketing system, makes it real easy to capture that for a subsequent sprint and make sure that it's prioritized. Or the third would be to dismiss it, which usually raises the hackles of security people. But if a developer dismisses it, it may be that they felt it was a false positive. It could also be that there's a compensating control, that I'm not testing my input because I just did that in another place. Probably not the best practice, maybe not the best example, but that might be a reason why a developer would feel that they could dismiss this vulnerability. And so what happens then is security can come along and deal with the exceptions. So after it leaves the developer's hand, after they've merged it in with a master branch and it's combined with other people's code, then the security team can, if you're using a single source of truth and a single tool like GitLab, then the security team is able to see what the developer did, what was dismissed, and maybe they disagree with it and turn it into an issue instead. But they're only looking at those things that the developer couldn't resolve themselves. So my short answer, enable your development team and use security for the exception processing. Good question.
Awesome. Thank you so much, Cindy. The second one that comes in is from, there's a lot right now. Matthias. Matthias asks, Matthias has just commented about the phone being distracting. Sorry about that, Matthias. But Colin asks, does dynamic DAS still have a place in cloud native?
That's a very interesting question. I would say yes, but here's my but. It needs to be done differently. And so, for instance, with GitLab, we can do dynamic scanning at this point of code commit. And the way that we do that is because it's embedded. It's part of CI. When the CI function spins up a review app, that review app is a fully functioning app that reflects the changes that developer made, and that review app gets dynamically scanned. So you're not scanning the entire application, you're scanning the code change. And that's what IAST was trying to get at, I think. So it may actually resolve the need for IAST potentially, because you do things a little bit differently. I do think at some point you want to do some penetration testing, whether it's manual or automated, at the end on an occasional basis, just for true ups, and make sure that you're not, overlooking something, or that your policies are not overlooking something. Because if you're automating your policies, you're going to have consistency, but you may need to go back and tweak your policies. And so doing some infrequent scanning of your entire application may help you tune those over time. Good question.
Awesome. Thank you. And then there's another question that came in from Michael. He asked, how about rotating credential passwords, certificates, tokens? How should that be implemented?
Yeah, so you definitely want to rotate your passwords, your secrets. All of that needs to be handled. You can use an automated tool to help you with that. That's probably the best way to do that. In fact, GitLab is part of our Zero Trust initiative, which if you Google Zero Trust and Kathy Wang, she's our Director of Security, essentially our CISO at GitLab, you can find other presentations on what GitLab is doing along the lines of the traditional Zero Trust to secure our endpoints and our users and that sort of thing. It might be useful for you if you're interested. But we are going to single sign-on with Okta and going to Vault to manage secrets. And so, there may be some best practices out there that you'd like to have a look at. But definitely you want to rotate your keys.
Thanks again, Cindy. We have a couple more questions, so let's keep going. Mm-hmm. Latif asks, how does GitLab will help do all this? So I don't know if you kind of answered it already earlier, so we can probably move forward.
Well, let me just make sure that I'm clear on what out of this direction here that I'm suggesting in terms of what we do. In development, I mentioned I went through the testing quite a bit. Now we do static dynamic dependency and container scanning, and we do license compliance. So we do all of those things as part of CI. It's in our ultimate product. So if you're using the free core version or even premium, you're not going to see those things. We've talked about maybe moving some of those scans down into some of the lower tiers, but in the ultimate tier, you'll see those scans as well as the security dashboard. And then from a production standpoint of monitoring and detection, with regard to monitoring microservices, containers, and orchestrators, this is an area that we call defend. So we've got secure more for the development side of things and defend more for the production side. And it's in a vision state right now. So we have plans. One of our first pieces is going to be kind of a next generation web application firewall. That's a piece that we're moving towards. And then auto remediation, we already have some auto remediation now for dependencies. So if you do a scan and you find a vulnerable code library, if there's a more current library available, we will download that and apply the patch. The next step in terms of making that even more automated is to actually run it in a separate branch, run the pipeline, and show you if the pipeline fails or succeeds. So we've started on auto remediation. We have a lot further to go and a lot more that we want to do there.
Thanks, Cindy.
Oh, one more thing I should mention in terms of the compliance piece. We have all of these compliance and audit controls now as part of GitLab. So when you use GitLab, all of these capabilities like segregation of duties and approvals and all of that is capable now. And so you can, from an audit standpoint, auditors love us. You can see who changed what, where, when, especially since it's a single tool. Now, you don't have to use all of the components of GitLab, but the more that you use, the more transparent that end-to-end piece will be. Sorry, I didn't mean to reel it back on you there, Agnes. Is there another question?
No problem at all. Yeah, I think we have the last one and a comment. So John asks, what tools are you using for scanning during CI/CD?
So today, what's built into the GitLab CI are the mostly open source scanners, but we're opening it up to additional scanners. they can be integrated as well. For static, we automatically determine the language, detect the language, and apply the appropriate static scanner. For dynamic, we use OWASP ZAP. For containers, we use, for Docker, we use Claire. And then dependencies and license management is our own proprietary scanner that came as part of purchasing Gymnasium about a year ago. And you might say, well, gosh, I could build it myself with you're just using open source scanners, but we're embedding it into the CI pipeline. So we're doing that heavy lifting for you, and the maintenance in terms of, you know, adding new languages and that sort of thing, scanners for other languages. We're doing all that heavy lifting for you. If that's not enough though, and you want your own scanner in there, you could certainly do the integration to pull your scanning results into the pipeline.
Thanks, Cindy. So Latif asked for a live demo, but Latif, unfortunately, I think usually our technical team does all the demos, so we will try to, it's probably a good topic for us to, you know, do our next webcast, a live demo for security, just GitLab security features.
I could do a little bit if they want. Okay. Let's see, let me, I'm gonna have to get out of this and show some ugly stuff on my screen here for just a minute, my cheat sheet that shows where I've got my
also, while we're waiting,
this is what the pipeline report looks like. And so what you see here is, this is, I've checked in my code and I've run my pipeline, which, let me go here and show you what the pipeline looks like. So this is what the pipeline looked like. So it automatically ran my container scanning, my DAS, my dependency, my license management, my SAST. And all of those results then show up right here, if you can see this. So this particular pipeline run detected 6 new and 3 fixed vulnerabilities. And so what that means is the fixed vulnerability, this was one that was auto-remediated. And then I've got this particular example doesn't have a whole lot of vulnerabilities in it. I probably should have picked something else if I weren't doing it on the fly. But the license compliance, same thing here in terms of it shows you where you're out of compliance. But for each of these, I can dig down and see more information. So what was, well, actually this one was remediated through an issue. You know, what was the vulnerability? I can look at the CWE, drill down, get more information about it. And if this one had not been remediated, I would have a couple of buttons here at the bottom that said, click to create an issue or to dismiss it. And I can see here that an issue has already been created. I can jump straight to that issue and see what it was. And this issue goes back into my planning. It's part of my planning system because we're using GitLab as a single application. Other people can weigh in, upvote it, comment on it, do all of those kinds of things that you would do, and that becomes my story for my developer in their next sprint. I know we're almost out of time, but I do want to show, let's see. I don't have a good example here of the, there's not enough vulnerabilities in this particular sample to show you, but you can jump straight to the line of code. And so developers really love that because I don't have to try to figure out, hey, I've got this vulnerability somewhere in the app. It's showing me exactly where it is. I click the button, it actually goes to the line of code. And because I'm in my code repository, I'm doing everything all in one place, then I can easily make my edits and resubmit my pipeline. Let me show one last thing real quick, and that is the dashboard. which so this is the security person's view of vulnerabilities. So these are, think of it as, these are the things that escape development. So either development said, I don't know how to fix it, it's just going to have to stay there, or they dismissed it. And so this is what's left. I've got 7 critical, you know, I can filter based on my confidence, based on severity, based on whether the type of scan it is. I can see how I've trended over time. I want to make sure my criticals are trending down over time, for instance. And then these are the actual individual vulnerabilities. So I can see here, this command injection was a critical, it's in test, by the way, it's in our test bed. So that's why we're not too concerned about it. But I can click this and go to the issue, and I can see that the status of that issue is closed. I could see what was done and how it was handled. Again, there's more here. Let me find one that's been dismissed. I wasn't really prepared for a demo to find one dismissed. Oh, here it is. So this one, it says it's grayed out and it says it was dismissed. I can undo that dismissal. I can get more information, which is essentially, you know, clicking in to see what happened, and I can see where it came from. This is the auditability that I'm talking about. Who changed what, where, when? What did they do? What happened? And all of that is right there. So let me jump back over there. I guess we're just about out of time, but in terms of, you know, if there's another question, I probably have time for one more. Would love to have you contact your GitLab sales rep or contact us, you know, as a result of this webinar, and follow up with you for a broader demo.
Thank you, Cindy, for throwing in the demo there. Super awesome to you know, get a live demo of our security capabilities. I think we have one last question from the audience, and I think we can close. It's from Adam. Adam asks, what external scanning tools are you planning to partner with?
So we have a list of several. I don't know that I don't want to quote them all here, but you know, all of the popular scanning tools. If you have some that you would like, my suggestion would be open an issue in GitLab, or look for an existing issue and upvote it with a, you know, additional thumbs up. Once we get enough momentum behind them, then, you know, we'll make sure that they happen. Some of them have been, in fact, White Source and a few others have come to us and said they'll do the integration because they really think that it's, you know, GitLab is popular enough that they want to be part of this. So that would be the other route, would be to reach out. If you already have a vendor, reach out to your vendor and ask them about the integration as well. Okay.
All right.